Let's take a look at this complex fraction. Now it looks different from the previous example because right now we don't actually have many fraction in the numerator and the denominator, but what we do have is that each part is being raised to the -1 power. So when we're working with negative exponents, is basically you're doing a reciprocal of what you have. So first, let me convert each part into a fraction. So AB, when I convert into a fraction, it's going to be AB over 1, still being raised to the power of -1, plus 2B over 1, still being raised to the power of -1, and then my denominator, 3A over 1, raised to the power of -1, and then minus AB over 1 being raised to the power of -1. So, the reason I convert all parts into fraction will help illustrate what to do when you have it being raised to the -1 power. So, when it's being raised to the -1 power, you're basically going to do the reciprocal of the fraction, meaning you're going to flip it. So, when you flip it, AB over 1 will simply become 1 over AB, and then plus 2B over 1 will become 1 over 2B. Now for the denominator, 3A over 1 will become 1 over 3A. And then minus AB over 1 will now become 1 over AB. So that's why this one is also called a complex fraction. Now here we actually have 4 mini fractions. So let's identify our LCD. So let's take a look at the number in our denominators, the 4 denominators. Mark them. We have the 3 and the 2, so let's write that down. We also have 2 variables, the A and B. So when we combine the LCD together by multiplying the 2, the 3, the A, and the B together, I'm going to get 6AB. So that's our LCD. So let me write down the complex fraction over here. One over AB plus 1 over 2B over 1 over 3A minus 1 over AB. So, just like how we did before with the 1 concept, where the 1 is converted to a fraction, and the numerator and the denominator is the same, in the form of the LCD, so I'm going to multiply the complex fraction by 6 over AB, 6AB over 6AB. This is the fraction that becomes a 1, but we're going to use the form of the LCD, distribute to the 2 fraction in the numerator, and distribute 2 fraction in the denominator. So when I multiply 6AB multiply to 1 over AB plus 6AB again multiply to the second fraction 1 over 2B. Now the denominator of the complex fraction, 6AB times 1 over 3A minus 6AB times the second fraction of the denominator, 1 over AB. Alright, so again, just like before, we're going to multiply the 6AB to the numerator of each fraction. So when I multiply the 6AB to the numerator, I'm going to have 6AB over this AB plus 6AB times the numerator, so 6AB over 2B. 6AB times 1 over 3A 6ab over 3a minus 6ab times the numerator, and then it's over ab. Now we're going to simplify each fraction. So 6ab over ab, the a's and the b's will divide into 1, and you're just going to be left with 6. The plus 6ab over 2b, the b will divide into 1, but the 6 divided by 2 will become 3, and I'm left with the a. Now the denominator part, 6ab over 3a, the a will divide into 1, but 6 over 3 will divide into 2, and I'm left with the b, so 2b, minus 6ab over ab, the a's and the b will divide into 1, and I'm just left with 6. Now in the numerator we have 6 plus 3a, and the denominator I have 2b minus 6. As I'm looking at each part, there's nothing in common, so I can't really simplify. If I try to factor it out, common factor, the common factor between 6 and 3a is 3, and I will have 2 plus a. And then in the denominator, the common factor between 2b and the 6 is 2. When I factor that out, it's just b minus 3. The one in parentheses, 2 plus a and b minus 3 is not the same. So there's nothing in common. The 3 and the 2 are common factors from the numerator and denominator, not the same. There's not much you can do. So proving that in each part there's nothing in common, so technically this is my final answer. The reason I factor was to show you that there's nothing really in common with each part. But sometimes it doesn't hurt to factor in case when you factor out, you might have a common factor, just like in 14.1 and 14.2. When you factor out, you might have common factors to divide. But here, I double check by taking out the GCF from the numerator and denominator and made sure that there's nothing in common. So therefore, this is my final answer. But again, it doesn't hurt to factor out to see if you have a common factor.